before we move, please answer these poll questions. Which fact or what factors impact your decision for making your workload scalable? So what make you think, or what things that you consider when you want to make your workload scalable? Please answer to your. So I have Pak Yusuf here for E, and then Pak Abdul Hafiz D, yeah, and then Pak Adi also E. So let's see what things that we should consider when we want to have a scalable workloads. In this module, we still will use the business requests, and then we will talk about the monitoring. We will talk about the alarm and events, and we will talk about load balancing, auto scaling, and then at the end of this module, hopefully you can see the solution for the business request. Now, what we have here, the operation manager needs to know what tools and services are available to monitor and log activities in AWS account. So please remember that one thing that you need to know in order to keep your operation running smoothly is to have a monitoring tools. Yeah. So in this case, we would like to know what service that's available in AWS in order to do the monitoring. And then can we be alerted when there is a change in our infrastructure? Yeah. Sometimes we need to know the changing or doing the changing, and before that we have to be alert first, and then can make a decision, or we can set an automatically making something that we can do the automatically when we know that there is something happens. Yeah. And then how do we add high availability to our Amazon EC2 workloads and distribute traffic across multiple targets? And then how we can dynamically increase and decrease capacity to meet the changing demand. So as you know that one of the benefit that we offering to the client when the client moved to the cloud computing is the agility, the capability of the cloud computing to be scaled, to be and have the scalable where you easily or dynamically can scale up or shrink the capacity, so you can have a better cost management, or you can have a cost optimization. Okay. So let's see from the first one. What tools and services are available to monitor and log activities to our AWS account? So there are several tools that we will discuss here. And for that, we need to know what the purpose of doing the monitoring. First, we would like to know or to make sure that our operational health is good. Yeah. Whenever the infrastructure is fine, then mostly we can ensure that operation is doing smoothly. The other thing that we would like to know why we do the monitoring is because we would like to know the performance of our application that running on the top of our infrastructure. Yeah. And then the other thing that we would like to know also that how actually our resource utilization. So this is things that's probably not very, I mean, that take not very concerned when you are doing the in the physical servers, yeah, because sometimes you already have to predict or presume the number of capacity, where only after the capacity will be full or will be reached out, then you have to think another uh, capacity. Now, since in cloud computing, you can have the scalable, then you would like to know uh, the 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 to make sure that all the resource actually the use of the resource or the utilization of the resources can be optimized. Yeah? Yeah, for instance, you don't want to pay something that you don't use. Yeah, uh, things like you still have to pay the easy to, whether it is you use or not. It's when it's running, you start to paying the bills to AWS. Now we would like to make sure that all the resources that running for in our environments are used uh, in optimize or optimize. I mean that's we optimize the use of this resource. And of course, the most important things why we do the monitoring, because we would like so to make sure that our resources are secure. Yeah. So one thing that, for instance, that's you you can detect there is hacking activities. One thing that you can see that when, for instance, that your resource has been used uh, in 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 very different pattern, for instance, yeah, the use of your memory, for instance, the use of your CPU, yeah. So that's can while you know that the process is not using that's much that resource that you need, yeah. So that's probably the sign of that you have to check your or maybe the sign of the security breach that happens, yeah. So monitoring can be one way to make our infrastructure, our resource, and our uh, service that we use secure. So what kind of monitoring we can have? Yeah, the first the first service that you can use is the Amazon CloudWatch. The Amazon CloudWatch will collect near real-time metrics and logs that's monitoring all the service in AWS. And then not only collecting, it also can give a response. And then you can also use the log of this CloudWatch in if you need to do the analysis. Yeah. So any change resource capacity can be monitored. Yeah. The health condition of your service or your resource. Yeah. And then it can initiate the change if necessary based on the rules that you can set. Yeah. Now this is an example of the cloud metrics. So the metrics are data about the system performance in the times in the period times, yeah, the times of the period that you set for, yeah. So for instance, that's in this example, yeah, you are monitoring the CPU EC2 CPU utilization, where it's the percentage of the utilization and against the time, yeah. So the CloudWatch can collect this data from your CPU, and then it can ingest this data, and then you can do the uh, you can visualize the data, and also you can do the analytics. So this is the types of logs that's available in AWS. You can have the CloudWatch log that's monitor all the data that's on your resource. Yeah, it can it can collect the log data. You can store and access the logs file. The AWS Cloud Trail is used to track any activities in your API usage. Okay, so remember that's actually in AWS. Yeah, if you remember, that's when we access AWS, we can have three ways to access AWS source resource. Yeah. So first, you can use the console. You can use your CLI, I showed you before, and then you can use also SDK. Yeah, these two are programmatic, and this is through the UI. This is UI, this is programmatic access. Yeah. Now these three actually using an API in order to access the AWS resource. Yeah. So that's why with this CloudTrail, any access that you use, any activity by an account or a user can be monitored by AWS CloudTrail. The other logs that you can monitor is the VPC flow logs. The VPC flow logs will monitor any traffic in and out the VPC. And of course, AWS also allow you to create your own custom logs that's according to your purpose and your use case. You can create your own custom logs. So this is just an example of how easy you can collect cloud logs using the CloudWatch. Yeah. Example that you have the log from your virtual machine, your EC2 instance, and you also collect your data from your server on premise. Yeah. So it can be collected by the CloudWatch, and then it can be grouped according to your use case, and then you can do the analytics on this log. Yeah. So for instance, that you can filter any error that's catch in the log file. Move to CloudTrail. As I mentioned before, it is monitoring the account activities. These account activities. So based on the API call, as I mentioned before, the three ways you can do is according to three ways that you can access your resource is through the console, through the CLI, and through the SDK. So that's all use the API call, and this CloudTrail will collect and log all these activities that use the API call. This log can be can be stored in AWS Amazon S3. So let me show you how we can see the plot trail. So here in my console, then I can search plot trail. Now here you can see from the dashboard. Okay, and then here you can create your own trail here. You can see also the event history. Yeah. So here you can see when it's happened. February 16, February 6 is today. So what I did, so for instance here, I delete the network here. I create a log group here. Yeah. And then what we can see here, so I choose this one. So if you can see here, we can, here in the record, we can have the JSON view here. Yeah. So you can see that there's a user identity. Yeah. So if you see this, it's the user identity here is the one that's make a request. In this case, it actually is created by AWS services. Yeah. And it's invoked by the RDS. So this is when I actually did my RDS, when I create or when I create a database. Yeah. So this is what happens. Yeah. Then actually the activity that's done by AWS services also will be recorded in the cloud trail. Yeah. So again here, now you can see here the resource. Okay. And this is the type of this cloud trail. Yeah. Now in here we can create our own cloud trail. Okay. We can give the name demo trail. Okay, since I don't have my S3, I deleted. It will create a new S3, and then it will also lock the encryption. Okay, and then I can also combine with the CloudWatch. So I put enable here, and then it's optional. I can put the tag. Yeah, but I don't think I have to do this. So just click next. Okay, this one is enter the campus alias. So probably have to check for the existing one. No option. So probably I'm unable, disable this. Okay, create a new trail. Yeah, can call this my load trail. Okay, it's successfully. So here my demo trail. Okay, not yet any event here because we just create this trail. Okay, so see that's quite easy to create a trail. So let's back to our slide here. So what we have in our JSON, it will record who make the request. Yeah. So here the principal's ID. Remember that principal is anybody or anything that requests for or operate the AWS services. And then the username. Yeah. Okay. And then it will also show you the request parameter. Yeah. When the request happen, and then what type of API call. In this case, this call try to stop the instance. Yeah. And when it occur, so this is the region when it's happened. And then the response. Yeah, at the end you can see the response is stopping. Yeah, meaning that the stop instance request actually successfully. Okay, move to the traffic. So we know that there will be traffic inbound and outbound to your VPC. Yeah. So this VPC flow logs will capture this all this flow traffic. Yeah. All the information about the traffic will be captured in the VPC flow logs. And then after that, you can use these logs and you can store the logs on the Amazon S3. Yeah. So it's considered as an object, or you can combine it to the CloudWatch, and then you can do you can, meaning that you can have CloudWatch logs based on this flow. Yeah. And then using this log, you can do the analysis. Yeah, you can do the analytic. Now, what you can get from the flow logs, yeah, the account ID, yeah, the version of the flow logs, the account ID, the network interface. Remember that all this internet traffic or any traffic through inbound and outbound from your VPC will also through the Elastic Network Interface. Yeah. So this will be capture also the information about the ENI, Elastic Network Interface here. So this is the idea of the network interface. And then when it's start and when it's end, and what is the action after the yeah the flow of this traffic. Okay, that is the monitoring. Give me thumbs up if you understand, or if you have a question, please ask me questions. Is it clear? Yes. Okay. Thank you, Pak Yusuf. Thank you, Pak Haidar. Now, we already talked about the monitoring. Remember that in monitoring, we're not only collecting a data, but how we can react when there is a change or something that we have to do when it's needed. Yeah. So meaning that we need to be alerted when there is a change in our infrastructure. Yeah. So one thing that we can do is having the CloudWatch alarm. What you have to do is to identify what metric. So for instance, that if you want to monitor your EC2, for example, yeah, when actually the EC2 need to be add, or to be scaled to add more instance in order uh, to handle the workload, for instance. Yeah. So you define first what is the metric, what is the that you want to monitor, and then based on that you can create an alarm based on the metrics that you choose. Yeah. And then based on the alarm, then you can define what action. So you collect the data, you watch the data, and then after that you respond if you need uh, to do something. Yeah, for instance, to whether to add more more power, for instance, add more to add more CPU, or doubling the CPU, yeah, or adding more memory, yeah. So we should do the action, yeah. So this is can be done using the CloudWatch alarm. Now there are three states of alarm. The alarm will be state okay when there is nothing that breach the 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 level or uh, the what do you call it, the threshold that you set. Yeah. And alarm when happen when it's also already exceed the threshold value that you set before. Yeah. Now, and then the other one is the insufficient data. Yeah. For instance, that's when you just running a service. Yeah. There's nothing happens. It just started. Yeah. It just doing the initialization, for instance. Then there is no enough data for from that collected by the CloudWatch, so it cannot be give give anything. Yeah. So it will give you a status or the states of insufficient data. Now, this is an example. In this example, yeah, the the alarm happens when you exceed this the threshold. See here, you set, for instance, the value is the 25%, meaning that's above 25%, it can initiate the alarm. However, here, when you see here, and it's this value of what you collect, yeah. Here, the matrix name is the CPU utilization. Which CPU that you monitoring, it is can be seen from this instance ID, and then how you, yeah, the way how you treat the data based on the statistic, you do the average, and then the period of collecting the data is 5 minutes. Now the alarm is set here. This is what you have to understand. The alarm that's set here is 2 of 2. What does it mean? It means that only if 2 times you breach the or you exceed the threshold value, then you set the alarm or you change the state to alarm state. Yeah. So this is what happened from first minute until the first 5 minutes here. Yeah. Actually, it's already above the threshold value. However, in the next 5 minutes, it's back under the threshold value. That's why you still have an OK here, because you set for 2 of 2. Yeah. And then here what happened in the the third 5 minutes, you see that it's above the threshold value, and the fourth 5 minutes, it's also above the value. That's why it will change to the alarm state. Yeah. But then after the fifth 5 minutes, the fifth periods of 5 minutes, it's back under the threshold value. That's why the states become OK again. Now here, when you have this alarm, you can do something. Now you collect the data, you do the monitoring. Here, when it's needed, yeah, you can respond to this alarm. But also that you can alert people who are in operation that need to know this situation. Now we will talk later in the serverless tomorrow, yeah, when we actually will make our architecture based on the event-driven architecture. So one of the important part of the event-driven architecture is you have the part of the monitoring, the one that's became the source of your event. Yeah. So Amazon CloudWatch is now part of the event bridge. Yeah. So it can send a message to respond to the environment, to activate function. Yeah. Again, that we already talked the Lambda. So this event bridge can invoke the Lambda to do something. Yeah. And capture the state information, including the state of OK, the state of alarm. Yeah. Then you can do something with this event bridge. So this is very important when you do the event-driven architecture. Now here, if you want to have the automated response, yeah, based on your cloud alarm, so here you collect the metric data of your EC2 instance. When it's above 90% of this CPU of your EC2, then it will send this alarm to event bridge, and event bridge can do something. In this example, it will send to the third-party monitoring tools. Yeah, it also can send to an SNS. Yeah, we will talk later also in the serverless. Yeah, But this is the servers, oh sorry, the service that provide by AWS, where you can send an SMS to your subscriber. Yeah. So example that you can, when it's happened, you can automatically send an email to your DevOps engineers or your networks engineers, yeah, or your or your cloud engineers, in order to let them know and do something to cope this situation. Okay, that is the monitoring and alarm. Yeah. So why we need to do the to have this monitoring again, to make sure everything runs smoothly. Yeah. When something happen, we need to know, or somebody that's responsible for that need to know, and then can do something, or you can do an automated things that respond to that situation. Yeah. Okay. Please give me thumb ups if it is clear. If you have a question, please give me a question. Okay. Can I move to next subtopic? Can we move to load balancing now? Clear? Okay. Pak Asri, thank you. Ibu Rahmah, Pak Yesaya. Okay, load balancing. Now, before we move to load balancing, remember that we have the concept of availability zone. Again, why we have this availability zone? To increase the high availability of our service. What does it mean? That we reduce the risk of the service will be stopped because there is a failure. Yeah. For instance, that's failure on your servers, yeah, on your workload, EC2. Yeah. That's why we put in different, we do the redundant, that's we what you call distribute to the multi availability zone. Yeah. Now, with that understanding, having said that, so what we need to know is how we can distribute this workload. Yeah. When, for instance, there is a traffic, internet traffic come to your VPC, to which request to your server, to which EC2 that you will assign to. Yeah. So that is when the load balancing come to the picture. So AWS has the elastic load balancing, where here it will receive the request from the client, and it will distribute to your multiple workload in the multiple AZ. Yeah. So it's automatically distribute traffic across the multiple target. The target can be your workload here. And mostly when we talk about load balancing, we are talking about how to distribute to the EC2. Yeah. And it also incorporates security features also, and also can check the perform health check of your instance. Yeah. So meaning that it will not distribute if to the specific instance, for instance, this instance, if this instance is not health. Yeah. It's unhealthy. Yeah. So it will distribute to other available instances. So there are three types of elastic load balancer. You can, it's depend on the OSI. Yeah, if you remember OSI models, okay, that we have the 7 layers of OSI. Yeah, so the top layers, when it is in the on the application layer, yeah, you can use the application load balancer that can handle the HTTP and HTTPS protocol. Then you can also distribute at the level of network network layer or transport layer, yeah, using the network load balancer where it can handle the TCP and UDP protocol. And then for the IP protocol, you can use the gateway load balancer. Now, how actually the ELB or the load balancer works? In load balancer, it will has the listener. And this listener will distribute to the specific target that you set for. Yeah. So when you make a load balancer, then you have to decide it to the target, which is can be your EC2. Yeah. And then you group this target. Yeah. Now, for instance, okay. Now, example, you have a different uh, availability zone here. Yeah. Then you can have your subnet here, different subnet. You can have subnet 1. You can have subnet 2. You can have another subnet here. And then say this is subnet 3. Yeah. And then you can have subnet 4 here. Yeah. So this is your internet gateway, your door. And then here you have your, for instance, your EC2, your EC2. And yeah, and then you have EC2 also here. Now, then you can group this EC2 in order to have better performance. Yeah. So then when you target if through your ELB, it will distribute the traffic to the EC2. Yeah. So it will check, including to check this the health of your EC2. Yeah. And then it will be distributed. Now, why we make this grouping? In case that, for instance, after even you distribute this, your workloads find that actually in order to handle the workload, you have to add to add more EC2, then you have to decide which group that you will add. Yeah. So this is why actually why you uh, it, you need to have the target group. Now, this is the common features you can see from the ELB. So it's doing the health check. Yeah, it's have the CloudWatch metric, doing the logging. Yeah, it's do the SSL offloading for the both for the ALB and NLB, but not for the gateway load balancer. And connection draining, and then also preserve the source IP address. Yeah. So this is what is important. Yeah. So if you can see here, most of the feature here can be offered by the application load balancing. And remember, this is on the level of uh, application or application layer. Yeah. So on the top layer of OSI, and then it actually handle the protocol HTTP and HTTPS. Okay, that is the load balancer. Any questions? Load balancer? Okay, you got this idea of load balancing because you want to distribute. Yeah, you can distribute based on percentage. Yeah, for instance, that's you divided 50% to one to EC2 one, and then 50% to EC2 two, example. Yeah, or group one, 50% to group one, target group one, and then 50% to target group two. Yeah, or you can even put, for instance, 75% to target one, target group one, and then 25% to target. It's you can do that percentage. Yeah, it's depend on the your use case. Okay, any questions? Any questions? Everything clear? If clear, please give me thumbs up. Then I know. If you have a problem, you can ask questions. No, it not necessarily. Pak Yusuf have a question. We have to use CloudWatch before implement Cloud Balancer. No, it's not necessarily. Yeah, but you can. Yeah, you can. How you know, for instance, that this EC2, for instance, that now it's not cannot handle the workload anymore. For instance, it's already close to the maximum capacity. Example, yeah. So in this case, if you want to know that, you need to have the CloudWatch. But anyway, CloudWatch actually already there in the in your monitoring. There is I think I saw you before that in EC2. Oh, I already delete my EC2. Let me check again. So let's go to EC2. Launch. Okay, I just go quickly here, put the default, and then launch the key pair, or I can select the key pair already. I can have my key pair. So training offer, launch. Now let's see to the instance here. So it's still pending. So I will come back later when it's already running, and we will see that there is actually already the monitoring built in the EC2. Okay. Am I answering your question, Pak Yusuf? Meaning that you can combine the CloudWatch and the load balancer, but it's not necessary that you have uh, to 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 implement the CloudWatch first, then implement the load balancer. Yes. Okay. So here it's already running. Yeah. So I can click now. So here automatically you can see that we already have this monitoring. You see that the CPU utilization, yeah, the disk rate. So CPU credit balance, this it's actually already there. Okay. Okay, Pak Ipin has a question, sir. Will this load balancer define the request load so there is no heavy traffic? Yes, actually that's one of the idea why you want to implement the load balancer. Yeah, so you can distribute this to the different or target group, different workload processor, for instance, EC2. Yeah, so that's the heavy traffic can be reduced. Yeah, so if you distribute in a better way, then your EC2 workload is become. I mean, that's less using the resource. Yeah, meaning that can imagine that example uh, your web application. Yeah. For instance, that's you have a similar application like Netflix, and you can see that whenever Netflix add a new movie, then everybody will watch that movie. Yeah, everybody will watch that movie, and then uh, the I mean that's the requests become high and higher. Yeah, so at that time, probably for instance, in during the weekend example, then the workload become high. Yeah, so if you only have one, then one target group, yeah, then it's become peak time and then difficult and probably can cause the crash. Yeah, so in order to avoid this happens, then you distribute the traffic. Am I answering your question, Pak Ipin? Okay. Now here I can create my load balancer. Here, you have to choose the three. Okay, remember that this is for the HTTP, HTTPS. This is for TCP, UDP, and TLS. And this is for the IP. Yeah. So suppose that I create this for the HTTP. Okay. Now, usually it will be interface facing, meaning that it will handle uh, the the internet traffic. Yeah. To give the name, my LB demo. Okay, and then you can choose this. Okay, since we only have one default VPC, yeah, then we can just do the default. Yeah, security groups, you also use the default. Okay, and then here we select the target. So now we don't have the target. Okay, that summary, check this internet facing IP4. Yes. Okay, at least two. Just check this subnet. Then I have to create target group. Okay, the target group is the instance. Okay, now I can select my EC2 that I create before. Okay. You see this unhealthy because so the total targets healthy 0, unhealthy 0. So it's still here because actually it's just we have to wait until it's ready. Yeah. Okay. We register the target. You have to include the pending. So this is how I distribute. Yeah. So now it's the problem is I only have one. Yeah. So it's only go to the one target here. So it's already registered here. There is no unhealthy, but there is also no healthy check here. Yeah. Okay, this is how actually we can distribute. So imagine that I have 1000 EC2. Yeah, so I can distribute this to all this as the target. So I can register the as the target. Okay, Pak Ipit, clear? Any other questions before we move to auto scaling? Unhealthy meaning that's your workload or your, I mean, that's your resource cannot do, cannot provide the service. So it's happened, for instance, for the EC2, it's not healthy when you just start. It's just start, so it's still doing the initialization, for instance, or for instance, that's when you, I mean, that's you scale, yeah, you scale and you scale up and then you scale down, yeah. Then it's need time when it's doing the initialization, yeah. So at that time, for you cannot provide the service, so it's unhealthy. Yeah, it also can be something wrong. For instance, that there is problem with the infrastructure. Yeah, so that can be happen like that. So it's classified as unhealthy. Am I answering your question, Pak Yesaya? Okay. So let's move to next sub module. It is about the auto scaling. Now, imagine here you already distribute your target. Yeah, you have grouped your target. Now, when you distribute the say you distribute the request, yeah, you distribute the request, but still the number of requests is too many. It's very big. Yeah? Again, example of this Netflix or World Cup, yeah, or Asian Cups. Yeah, everyone want to check from all over the world. Yeah, now what you can do if your server cannot handle anymore? Yeah, one thing is to add more server or to increase the capability of the capacity of the server. Yeah, for instance, from the CPU, for just example, from you can scale up by doing the, for instance, from Intel i3, you improve to Intel i5. So this scale up, yeah. But also you can horizontally, meaning that you have now only have two server with i3 CPU. Yeah. Now you can add another 5 i3 CPU. It's called the scale out. Yeah. So you can scale out horizontally. You can scale up to the better yeah, to better resource. Yeah. Now both you can do, but how you can do this if you cannot do automatically? Yeah. Because if you do the provision, yeah, launching the EC2, then it will take time. It will not handle the situation where it must be handled as soon as possible. This is the reason why you have this AWS auto scaling. Yeah. So the auto scaling will explore your application, and when it's necessary, example, that's you are almost reach the capacity or the capacity of your workload, yeah, and that you can handle with your servers, then it can be scale, yeah, and then it will optimize what scale that you can do, and then it will track the scaling and as it happens. Now here, that's we already mentioned before that this load balancer is used to distribute the the traffic. But at the same time, you can combine with having the auto scaling group when actually after you distribute this, still you need to add or to scale up the numbers or scale up the the capacity of the instance. Then you need to do the auto scaling. Okay. What it can do is launch and terminate your AWS resource based on the specific condition. So it can add horizontally, add more, or it can change from lower CPU to higher CPU. So that is scale up. It can be done both by the auto scaling group. And then you see that's in the demonstration I did, we have to register the instance, but this can be done automatically by the EC2 auto scaling. Now, this is why we did the elasticity in our solution for our business. So this is the presume the infrastructure cost. If you, the more business increase, the more that you need your infrastructure. You have to increase your infrastructure. For instance, that if the Netflix having more and more user, then of course the Netflix should add more and more infrastructure to handle the request from the user. So this is the infrastructure cost, again the time. This is the traditional way to solve the problem. You add more server, you buy more server. Before that, here you can add server. But you need time. You need time to do the purchase order. To wait the assembly. And so forth. Only after that you can enjoy again. And then when it's necessary, you scale up again. So this is actually the capital expenditure when you use the traditional on-premise server. But what happened? The actual demand actually is not linear like this. Sometimes it's not. Sometimes it's go up. Sometimes it's go down. When it's down, you probably wasting your physical infrastructure here. When it's peak like this, probably you may lose something. For instance, that you crash your website, you crash your, and then it will not give a good experience to your customer. So this is when you lost the opportunity costs. So in order to meaning that you already invest here, but actually the demand is going down. And then here actually you lost opportunity. Because your infrastructure is not able to cope your business anymore. So for instance, this is when actually the website crash. Your system not available. So this is your lost the opportunity. So what you need is the way that can handle the demand. This is why we need we use the auto scaling. When it's necessary to go up, then you add more server. When is the request is less, then you can shrink again. Now this is the way that you can optimize the cost. Now, how you can do the automatic scaling, because the auto scaling has the launch template. So you define what resource you need. So when it will be launched automatically by the auto scaling. And then you also have the Amazon EC2 auto scaling group. Yeah. So you can decide it when it's needed and how many that you need. Yeah. So this again, it can be fit to this demand. And then you can put your auto scaling policy. Yeah. How long that you can stick with your additional EC2. Yeah. When it be should be shrinking, the numbers should be shrinking. Yeah. Or you can lower down the CPU capability. Yeah. So it's depend on your auto scaling policy. So this is the launch templates. You mentioned the instant type. If you remember, that's when we launched the EC2, we have to decide what is the instance. Do we need the EBS volume? Which MI that we will use? Yeah, remember that we have this when we launched our EC2, and then we have to decide that the elastic network interface that will be used, and any user data that need for the automation during the launch of your EC2. Yeah. Now, you can use this through the console management. The same, you can use CLI to launch the template. And then you can use the SDK in order to launch the EC2 instance. And they are exactly the same because you use the same template. Now, for the group capacity, again, that's you can add, but you have to put the maximum, but you also can decide the minimum. Yeah. Now, there's a desired one that the number that's actually in standard or the normal way that you want to have. Yeah. Okay. The analogy like this. Yeah. The analogy like this. It's like your air conditioning remote. Yeah. The air conditioning remote. What is the minimum temperature there? Can you set for 0 temperature or 10 Celsius temperature? Can you set that? No, sir. So yes, I think most of the air conditioner will minimum 16 or 18. Yeah, mostly 18. And most of the remote control, the air conditioner remote will be 18. And then what is the maximum? Can you have a maximum 40? I don't think so. Yeah. So the same like that, you have to decide that what is the minimum maximum EC2 based on probably it's how strong your financial to pay that. If you put 1,000 more, for instance, yeah. So you need to really to put the maximum, maybe maximum 6 or 5, yeah, maximum that that you want to have, yeah. Minimum that you cannot have less than that, yeah. For instance, it cannot set 0, yeah. At least one, yeah. So in the normal way, you will have 2. So when one is failed, you still have another one to handle the workload. Example, yeah. So this is the group capacity that you can do, yeah. You can decide the desired capacity, the minimum, and then maximum. When it's needed, it will create a new instance automatically, and when it's necessary, it will be deleted. Yeah, it will be deleted and returned back to the desired capacity. Now, in order to invoke Amazon EC2 auto scaling, it will check the health status. So for instance, that's when it's this one in the health status is unhealthy, yeah, but you need you need the three at minimum three EC2 operate in order to handle the workload, then it will create another one. Yeah. So this the health status of the EC2 can invoke of the auto scaling. This when actually the CloudWatch is important, Pak Yusuf. Clear, Pak Yusuf? And then the cloud alarm, for instance, that's you set the maximum value or the capacity of CPU usage, yeah. Say for instance 75%. Yeah. So when exceed that's 75%, yeah, then it will create another one. Yeah. Or you already know the schedule. Every weekend, people watch Premier League, yeah, Premier Leagues. So that's why you know that every weekend it will be high requests. Then you schedule every weekend. You actually will create another two EC2. But also you can decide it manually. But again, this is one thing that you want to avoid because again, it's when you have the easy things to do automatically, why you should do manual. But if necessary, you can do the manual scaling. So when you use the schedule, when it's for the predictable workloads, as I mentioned before, example, every weekend, yeah. So you use the dynamic auto scaling. For the general scaling, it will follow your on demand or the demand of your workload. It will follow it, yeah. Whenever the increase requests or the decrease of the request, it will follow the pattern. Yeah. Now you can also use the the AI. Yeah, that's actually used in AWS. That actually can use the pattern of your usage before and then decided for your auto scaling. Yeah, so that's called the predictive. Yeah, it's most intuitive to use. Yeah. So here, no need to manually adjust the rules. Okay. Now, I think this, you already know this. Still remember? Do you remember, Pak Yusuf, what is on-demand instance? Saving plans. How many type we have saving plans? Bu Gil? Yeah. How many types we have? Remember, we have two types of saving plans. Yeah. We also have on-demand and then spot instance. Remember what is it is cheap up to 90%, but remember that's also at any time can be taken back by the AWS. Yeah. So the same is the same. I mean that's the same rules that have what we learned before in compute in module 4 also apply here to your instance here. Okay. Okay, that's it. So here, I think that we can answer the question. Okay, I think that's here. we already have we can answer this. We have the CloudWatch here, CloudWatch. We have the CloudTrail. Yeah, we have VPC, VPC flow lock, and then we also have the custom lock. Yeah, so this is a lock activity that we can do, and then we can set the threshold. Yeah, here where we can have the 3 states of alarm. It's okay. Yeah, remember that. Oops. It's okay. And then you can alarm. And then you can have the what you call this? The alarm and insufficient data. Yeah. So this is, we can set the threshold at CloudWatch alarm. So how we do this? We use the ELB, Elastic Load Balancer, where we can we have the application load balancer, yeah, for HTTP and HTTPS protocol. And then we have the network load balancer. Sorry, this will be where actually this is the UDP and TCP. Yeah. And then the other one is we have the gateway load balancer where actually it's handled the IP. Yeah. So how we increase this? We can use the auto EC2 auto scaling. So again, I think here we already discussed about the monitoring. We talk about the alarm and event. One more thing, that's the CloudWatch also can be combined with the event bridge event bridge. Yeah, you can use the alarm in order to respond. Yeah, in order to alert, respond with the action. Yeah, respond with the. Oh, where's my pen? Oh, this. You can respond. You can respond with giving an alert. Remember that we can send SMS using SNS, and also we can take we can invoke something. Yeah, we can invoke the lambda. We can invoke things, or we can invoke any action. Yeah, so this is giving the action. Yeah, and then we talk about the load balancing, and we talk about the auto scaling. Okay, I think that's all. So now in the capstone, now you can add your auto scaling groups for your distribute EC2 in multi-AZ here. So let's do the knowledge check. Which option is valid target for application load balancer? Remember, application, the target. What target you can use? Yeah, the instance. Yeah. So availability zone is not the target. Bucket also, S3 bucket also not a target. VPN also not the target. So that's correct. EC2 instance can be registered, yeah, as a in the target group. An application support team has application with unpredictable. So remember this. When it's unpredictable traffic pattern and at least two in and on the at least two instant, they want the CPU to stay about 75%. Which Amazon auto scaling strategy that you should choose? Which one, if unpredictable? Okay, schedule, no, because schedule is predictable. It can be dynamic or predictive, yeah, or it's not manual, so it's not correct. It's not correct, yeah. So between dynamic and predictable. So the predictable actually it's used the AI in order to see the pattern. Yeah. Now the most close to this one is the dynamic. So this is the answer. Yeah. The same like you do the, I think that every of you doing the AI, you know that's, yeah. Before you can make a decision, you have to the data or you see the pattern first. Yeah. Now that's maybe too late when you can use the predict. If you already run for instance a long time and then you already have a pattern, then predictive can be an option. So the one that like me, we just create an EC2. I don't think that we use the predictive is the best, yeah, because it has no pattern on that, yeah. So just use the dynamic. And then which service can invoke action based on the, okay, again, invoke here, invoke the action based on data from account resource and support third-party management account. Okay, what is the event source? Remember? Yeah. So the logs cannot invokes. Yeah. Amazon event bridge, yes. The cloud trail is audit trail is all only auditing, yeah, for auditing, not to invoke. Yeah. And then auto scaling actually can be invoked, not doing invoke the action. Yeah. So the best answer is B. Which option are valid for the alarm states in Amazon CloudWatch? So we have three states. We don't have ready. Do we have alert? No. We have alarm. We have OK, and we have insufficient data. Yeah. So this is the two state of three state of alarm states. So which option are use case for cloud trail? When we use the cloud trail, remember cloud trail? What we use when we use the cloud trail, provide real-time observability of the resource. No, this is CloudWatch. This is CloudWatch. Yeah. Store log data as record of account usage. Yes. This is cloud trail for the account. So it's audit trail for the account usage. Yes. Then this is for the cloud trail. Log event for particular service application. No, it can use the CloudWatch also. Yeah. Capture root login failures. Again, anything related to account, it will be collected by the CloudTrail. So this is true. So this is again not true. This is CloudWatch. Good. Pak Adi, BND. Okay, we finished this module 7. We have a break for 10 minutes. Here, I heard the Asar Azan. So let's back in 15 minutes. So let's back on 340, 340. Oh, sorry, 350. Okay. Now, any of you familiar with this solution or this services? AWS CloudFormation, AWS Elastic Beanstalk, and others. Or anybody knows about Terraform? Anybody heard about Terraform before? Anybody? Okay, yeah. Actually, to be honest, I'm not really familiar with CloudFormation, but I used before the Terraform. Yeah, for me, I feel more comfortable with the Terraform. Now, in this module, we will discuss about the AWS CloudFormation. Actually, it is an infrastructure as code, yeah, where we can create or maintain and manage our infrastructure through the code, yeah. And then we will talk in general about infrastructure management. And then we will also talk about the Amazon Code Whisperer, where actually using the AI in order to assist the programmer to create the code. Yeah. Now here, these two questions from the CTO. How can we simplify our cloud infrastructure builds? Yeah. And then how can we deploy, maintain, and scale application of the cloud? So here, that's before this, you see that we create the resource through the console. We also can do through the CLI. Yeah. However, is there this request asking about, is there any means that we can more simplify that we already have before? Yeah. So if you see what I did through the console, it's almost impossible that we can automate this. Yeah, that's one thing. The second one, when I did for instance, the launch of the EC2, there are so many options that I can have where if somebody else that we work together do that what is supposed to do, it can have a different template. Yeah. So it can cause the human error in order to launch the EC2. Now, how can we make this standard like we already have a template before? But remember, that's the template we create. Also, we have to create first from the EC2, or we can use the like AMI builder, yeah, the image builder, yeah. So this is what we talk about, the importance of the infrastructure as code, where we can maintain, deploy, maintain the application or the service that we use through the code. As I mentioned before, that's infrastructure as code. That's meaning that you create, you maintain, you deploy your service through the code. Yeah. So what is the benefit of using the code in order to create the infrastructure? First, you can easily to save the template, yeah, and then it can reusable. Yeah, you can use the same. You can easily uh, to to do the edit, yeah. So you don't have to go to the console, for instance, to doing something, yeah. So you can edit the code example, yeah. Now let's make the infrastructure is more easily to be maintained, yeah. So you can replicate, redeploy, and repurpose your infrastructure using the code. You can also control the versioning of your infrastructure, yeah. So that's the also the important of the infrastructure as code. It also can detect any drift, and if necessary, it can roll back to the service that where you can get the good state. Yeah. So this is the architecture template. You write this architecture through the code. Yeah. Then you deploy to the AWS environment here. One of the benefit of infrastructure as code is the reusability. You can use the same template in order to create or to launch the resource. In this example, you can use the template and tell the auto scaling to launch the EC2 based on the template. So you define here the operating system, yeah, the family, the CPU family, yeah, the EBS volume. You put in the template, it will create the same again and again. And you also can easily to update. Yeah, when you update the template, the one that actually will be launched will be have the align with the update. Yeah, so the update of the template. Now here the service that you can use in order to do the infrastructure as code. So the AWS has what we call as AWS cloud formation, where you can create the template and upload the template to cloud formation, yeah? And then it can create to the API request, and then it can form the on the stack of the resource. Yeah. There are two ways that you can create the templates for your cloud formation. Yeah. So you can use the JSON or you can use YAML. Yeah. So some people prefer YAML because it's less like this cruel these things looks make difficult. Yeah. But some people also like to use this because it's more understandable. Yeah. So you can write on JSON or YAML, and then you describe the resource that you want to create or you want to modify. Yeah. So here the resource is actually the S3 bucket. The good things of having this in code, you can review the code like you review your programming. And if you modify the code, you can also have the version control. Yeah. So again, that's the stack is the collection of the AWS resource that are managed as a single unit. It can be deploy and delete resource as a unit also, can update the resource and setting on the running stack and support the nested stack. Yeah. So here the template, for instance, the stack is for the creating the VPC, and then the stacks will be create and deploy the Amazon DynamoDB, Amazon RDS, and Amazon EFS. The other stack is to create the EC2 and also the Lambda. So meaning this is n as the single unit. With this stack, you can create DynamoDB, RDS, and EFS as one unit. Yeah. So this is different when you do through the console. Then you have to go to the DynamoDB to RDS first, and then to DynamoDB, and then to the EFS. Yeah. The same like happened in the EC2 and Lambda. So here you can already in one unit. So here, how it's actually can be applied to the multi-layer architecture. Yeah. So you can create the front end with the stack. Yeah. And then the back end, the shared, and the base network, also the identity. Here you define the users, the groups, and the roles. Yeah. And then you create the VPC, and then things that need for the VPC, like the internet gateways, the VPN, the net gateways, the subnet, yeah, also. And then on the top, and that's you can create the database, and then the what you can do this analytics, yeah, and then you can create the web interface on the front end. Okay, is it clear? What is the benefit of infrastructure as code? So I think that if you're familiar with the HashiCorp Terraform, I think that's easy to understand this. Yeah. And Terraform is, for me, is more easy. That's why I also use the Terraform. And Terraform can be used for AWS, can be used for Azure. I'm not sure the rest, but I think that also can do for other cloud services. Okay, any questions? If not, then let's move to the infrastructure management. Yeah. So actually, there are options for the deployment and also the management. For management, we can use the AWS system managers. Yeah, but for the deployment, you have a couple of choices where it's give you a trade-off. Yeah, the more go to the left, it's more convenience. You just use. I mean that you can be used easily, but uh, the more right, for instance, for the AWS code formation, it's more control, it's more programming things. Yeah, so it's less convenient for some people. Yeah, so it's really an option that you can choose. Now the elastic beanstalk, what is good things of elastic beanstalk here, you only concentrate on your code, while anything about the server, yeah, this interpreter, the operating system, and the host will be managed by elastic beanstalk. So that's things that make you meaning that's really help reduce your effort, yeah, and then it can also help you to concentrate on the code, and then you can improve your I mean that's it can improve your innovation and other things. Provision and operate the infrastructure, meaning it's handled by Beanstalk or AWS. Manage the application stack for you. Yeah. So everything that is created and automatically scales your application up and down. Sorry. The other solution is the AWS Solution Library, yeah, where actually it's the pre-built reference architecture. What does it mean by a reference architecture? It's the architecture is already reviewed and then recommended by AWS. Yeah. So, and then, yeah, you can use this easily and also safely to deploy to your using this solution library. Yeah. And again, it's the meanings of the reference architecture is already reviewed and already approved by AWS architect. Yeah. So you can have this script, yeah, and you can use this your AWS solution library through your code formation, and you can, yeah, you can use this using your account and then deploy to your account. Things like this, you can create from the scratch for using the cloud formation, but you things like use the Python rather to make a library. You can take a library, for instance, for Python, you can use Panda. You can use, but you can still, if you want, you can create from the scratch. Yeah, the same. The cloud formation templates you can create from the scratch, but also you can just import from the solution library. So the other one is the AWS CDK. Use any support language to generate the template. Support the autocomplete and inline documentation. Again, that's you just meaning that's it gives you the autocomplete that what according to the best practice of the code that you need to create. Yeah, and then has proven default reusable classes and can be provisioned multiple in the multiple environment. Okay, so using this AWS CDK app, you can create the template and then you upload the template, the code formation. The code formation can create this as a stack. Okay. Now that is for the deployment. Okay. And this one is for the managing your infrastructure, yeah, or your system. So it's AWS System Manager. That's provisioning and entertainment, that you can do the configuration management. You can also do operation and compliance management, and you can also do the monitoring. So this is a different kind of the monitoring. If you remember, the CloudWatch is collecting the data from your metric. Yeah, you decided your metric. This is a different monitoring. Yeah. So for instance, that's here it can monitor the patching. Yeah, you can patch automatically using the AWS system managers. Okay, can we continue? Okay, so this thing, I think that's most of you as a AI person will like it. Actually, AWS already have the AI implement for the IDE or integrated development environment. Yeah, same or some people said better than the Chat GPT. Actually, it's called the Code Whisperer. So it's AI coding companion. You just give. This is what I know, that you can give a comment, and then it will create you a suggestion of the code, and you can edit. Yeah, or you can just use the code. So generates code suggestion based on the comment and existing code. Offer real-time support for your code authoring directly within your IDE, and then help you to check the vulnerability on your code. And then it's used the reference standard, that's known standard, or again, that's used the reference architecture that's already proved, and then used in the as a best practice. Yeah. Now here, example, you just give a comment here, create an S3 bucket name CW95323. Yeah. So it will create the this this code for you. Yeah. So this is S3 create bucket, which bucket name is the CW59323. Okay. So code suggestion, code completion, code generation from the comment. Alternative code suggestion, you can choose a different code, the same like you do in the ChatGPT. If you're happy with that, with the answer from ChatGPT, then you can ask the alternative. Yeah. So the same, it will suggest you the code, but you can always ask for the alternative. So here example that will the code whisperer also will do the security check. Here, for instance, that's open file paths here. Yeah. So this concept part with unsanitized user input can lead, yeah, meaning that's this give the vulnerability of in the code, yeah, in your S3 later on when you running this code. So this is useful for the developers. It's increased the velocity of coding of the developers coding. Yeah? The developer will spend less time in writing code and also receive the direct assistant within your IDE, and then also will able to implement the secure from the, I mean that it's a secure by development. Yeah, meaning that when you develop, it's also tell you where if there is a vulnerabilities. So for the company, it's used at all experience levels. Yeah. So even if you want to train your developers, for instance, you can use the Code Whisperer. It also supports the open source attribution, reduce the risk of security vulnerabilities, and increase code quality and developer productivity. Okay. So that's all for this automation. Okay. And here we talk about infrastructure as code. Okay. We talk about the Amazon code formation. And then we talk about the infrastructure management using the AWS system management. And we talk about the Amazon Code Whisperer that's useful when you do the programming. Yeah. So this is related to the infrastructure as code. Yeah. So even for the infrastructure as code, also you can use the Code Whisperer. Any questions? I think it's clear. So let's do the knowledge check here. So what is AWS Cloud Formation Stack? Please type to your chat. What is your answer? Anyone? A, all of the provisioned resources that are defined in Cloud Formation template. Yes, it will be transferred to the to the stack, Cloud Formation stack as a unit. Yeah, all the resources are identified as drifted. No, a condition which resources are added to the on the top of each other. No, and the properties of a single resource. No, it's a single unit. Yeah, that you can have more than one resource. Yeah, so that's why A is the best answer. So select two. Which statement are benefit of using Cloud Development Kit or CDK with AWS Cloud Formation? Developer can use common programming language. Yes, it's the same like other IDE. It support the common programming. Yeah. Bug discount. No, it's not about the discount. C, developer can pre-configured resource with proven default. Yes, this is another benefits. Components are limited to single resource. No, not limited to single resource. Using AWS CDK does not require AWS account or credential. No, it's inside the AWS environment. That's why you still need to have your account and credential. So the best answer is A and C. Yeah, that's right. Okay, that's all for module X. Module 8. Do you want to have break, or we can continue the last module. What do you think? Okay, let's have a break for 10 minutes. For 30, we return back. Is it okay? Okay. So what is container? So before we try to understand what is here, I will give a little bit what you call a bit history. So the beginning, we have the what we have here, the physical server. Yeah, the physical server that's actually provide you, for instance, your web application. Is provide also your database. Everything is here. Yeah. Now then people move to virtual machine where your server, you can here have a different on the top of your OS, you can have another OS, yeah, or you, and then you can separate, for instance, here based on Linux for your web, and then Windows for your database. So now you have separate, you can separate the web and the database, yeah. So this is one of the reasons why people use the virtual machine. Yeah. So because in the from the perspective of security, when this part actually compromise, it will not affect to the other part. It's really separate. Yeah. And then you can also utilize with the other resource of your infrastructure resource here. Now the problem of the virtual machine, yeah, every time you create a virtual, yeah, it will create, it will use the RAM, yeah, and all other resource. So for instance, that you have 20 gigabyte RAM. So it will, if you have two virtual machine, this 20 will be used. Yeah. So it will be used for this machine. It will be used for this virtual machine 1. It will be used virtual machine 2. Whether you use or you run anything in this virtual machine or not, your resource here is still be divided. And this is one of the problem in the virtual machine. Now, then people move to so-called container, where actually on your machine, and then you have the container engine here, where you can put everything, the application, the OS, anything, without having the same problem like you have to divide your resource here. So this make container more plausible to the developers, because then you can yeah, have a better what you call this, better utilization of your resource. Yeah. Now this is one of the historical why people use the container. Yeah. Container also means that you have everything here. It's can serve you. Yeah. So you can have an OS, you can have the application. Everything is already ready and it can be run. Yeah. So that's make people turn to container, and that's the reason why people use the container. So inside the container, it can, again, the same, that's the concept of repeatable, self-contained, meaning that it can sufficient itself. Yeah, it faster spin up and down than the VMS, virtual machine. Again, that's because, yeah, again, that's you have to distribute your resource when you use the VM machine. Yeah, so that's different when you use the container. And then it's portable. It can move from one platform to other platform. Yeah, and also it's scalable. Okay. Now this is example of, again, the monolithic. Yeah, and then why this concept of container is really useful for the microservices. Yeah, and also if you remember that we're talking about the uh, what you call, yes, Jason, the oh, I can I can have my words. Yeah, but anyway, this is why container and microservices can be complement each other. Yeah. So this is the monolithics, where everything is you can have in once. Yeah. So this is for the reporting, this is for the marketing, and this is for the ordering. Yeah. So it is in different solution. Now in the microservices, this ordering can go for the others. Yeah? Reporting also can go for others, and then marketing can do for others. Yeah. So you don't need, for instance, the email here. So to have okay. So you, yeah, for instance, that's here you decouple this the relationship between the sales history and then inventory, the sales history to the email. Yeah? And then for instance, that here you can also have this uh, order history, and you also have order history here. Yeah. So this is what we call monolithics. Everything it's doing and tight couple each other. Yeah. So rather than to have redundant order history in this solution, why we don't have only one email, one order history, one sales? Yeah. So that's what we call is the microservice order application. Yeah. Now this is the level of abstraction I mentioned before. Yeah. So this is when you use the bare metal server for your virtual machine, and then this is what happened in the virtual machine. Yeah. So every VM will need the guest its own guest OS. Yeah. And then it will take all the resource from this machine. Yeah. In containers, you see this, everything actually running on this container machine. And usually and commonly used is the Docker engine, yeah, the Docker engine. And on the top of that, every it you know that it's the container, yeah, can have its own solution and its own application in own library, yeah. So here you need to create 3 virtual machine. Here you don't need to create anything, you just have the container, yeah. So that's why container is more robust compared to virtual machine. The same like before, that's this with virtual machine, then you isolate this OS, yeah, for specifically for this application only. And then here it's this guest OS is for this application and library, this only, yeah. Now this is that create the problems and less robust compared to the containers. On AWS provide the AWS that can have the container for the EC2. So the running containers directly to Amazon EC2 requires you to manage the scaling, connectivity, and maintenance. Yeah. So when you have the containers and then inside the container you have your EC2. Yeah. So you you have to manage the scaling, connectivity, and the maintenance. Yeah. Now, the better way is you can use the container orchestration. Yeah, the container orchestration tools, which can do the scheduling, placement, and networking and monitoring of your EC2. So if you see here, the more that the better service that the AWS provide, usually it's make you less effort to do the maintenance, or it can make you have more automation. Yeah. So that is the basic concept of the cloud that align to the concept of the cloud computing. Okay. Is it clear why we use the container? What is the benefit of container? And why container is important and why the microservice is important? Give me anything, emoji. Clear, thank you, Pak Yusuf. So now, what's container services that we have in AWS? So running containers on AWS, you need to do you need to have the registry where you can pull container image from the registry, which is actually this is where, oops. So this is where actually you can store the image, the container image. Then in AWS, you can use the ECR services in order to pull the container image from the registry. And there are 2 orchestration tools available in AWS. which is one is, as I mentioned before, EKS. For the one that already use or familiar with Kubernetes, then you can use the EKS, or you can use the one that's originally created by AWS, which is the ECS. And in order to hosting the container, you can host at the EC2, Amazon EC2, yeah, or you can also have the platform called AWS Fargate, which is actually this is serverless. So here you have to maintain your virtual machine, yeah, which is the EC2. The EC2, it's still yeah, you have to maintain the EC2 itself, and then on the top that you can put the container, yeah. But if you don't want to busy with the infrastructure, then you can use the Fargate. So here again, that's a monolithic forum application. You have the user service that use the service container image, and then here, rather to have this, you can separate this, yeah, this monolithic into microservices user, which is it serve the user service for one container image, and for the topic services for your SNS, yeah, you can use the one container image, and then for the message service, you use also the another container image. And you can store your image into the what we call is the registry that in Amazon it's served by the Amazon ECR. This is for the orchestration of your container. Yeah. So you can choose again whether ECS or EKS. So for ECS, it's the managed container orchestration service tightly integrate with the AWS to pulse the image from your registry ECR, and is a service scale service capacity by managing the container count, and then ECS cluster scale hosting capacity. Yeah, so this is when you use the ECS orchestration. What is the feature of ECS? It's fully managed. It's server service discovery. You can find the service, yeah, and then which the service discovery, meaning that you can use to register your ECS to DNS names, yeah, and then it really works for the common development workflow, yeah, and then also it's work with the AWS integration, yeah. So it's integrates with ECS and ECR, yeah. So again, ECR where you can, ECR is where you can store your image, and ECS can actually pull the image, yeah, and then do the orchestration. So it has the integration with the ECR. So this is oops. So this is way to move from monolithic to container-based microservices. Use the load balancer, and then use the API, for the user and the topics and the message, and then connect to the EC2 instance. Yeah. So again, that's application load balancer. Remember, that's handle the HTTP and also HTTPS, meaning that it can sending the web traffic based on the API and then distribute to the microservices. So for instance, this microservices is only doing the job to for the user ECS services, and this is for the topic, and then this is for the message. Now the other orchestration that you can have is Amazon EKS. Kubernetes itself actually an open source that's widely used to do the containerization, yeah, and manage the containers, yeah. Now, since it's widely used, then the Amazon, the AWS also provide the Kubernetes orchestration on AWS by providing the Amazon EKS. Now you can scale the application with the EKS, and it seamlessly move the application. You can add new functionality and you can run anywhere. This is why the Kubernetes actually very famous among the developers. The Amazon EKS run Kubernetes on the AWS. It do the provision on Amazon EKS cluster. You can do for the Fargate. Remember that this is serverless, meaning that again you don't have to maintain your the operation of the server. Yeah, while you can also do the Amazon ECS EC2, meaning that this container can be put on the EC2. That means also you have your Kubernetes on the EC2, but you still have to maintain your EC2 as a server. And then you connect this to the Amazon EKS and run the Kubernetes application. Again, this is the serverless service for the containers. Yeah. So you build the container image, whether again, that's when you build the container, you can store the container on the registry, yeah, and then you can pull the container and can do the orchestration, whether to use the ECS or EKS. You can deploy that again either to Fargate or to the EC2. Yeah. So if you choose the Fargate and it is you launch the container and forget about the infrastructure. Yeah. So it is serverless, everything handled by the AWS to only concentrate or concern on your container itself. Yeah. So the Fargate will runs your container on behalf of you, and then also to manage the containers. So this is the trade-off, yeah, between less effort and you have to give more effort, yeah. You choose the orchestration. If you choose ECS, it's more, yeah, you can have, you spend less effort on that. And if you want to have more control, then you can use, and you stick to use the Kubernetes, then you can use the Amazon EKS. And then the hosting type, it's serverless, is less effort. If you want to still to manage the server, you have more control on that, then you can use the Amazon EC2. Okay, I think that's all we cover on the container, the concept of container, the container in AWS. Yeah. Now I think that's we can answer the questions. Yeah. Why we use this container concept in AWS. Yeah. So here we want to have the component of our application more independent so that change in one service not affect each other. So this is actually what we discussed about the monolithic application, and then we use the microservices. Yeah. So with microservices, any changes or every uh, every service will independent each other. Yeah. And then yeah, that's why that's any changes will not affect to others. So we also discussed about the benefit of containers, yeah, which is better than VM. Containers are better than VM, and then it's better also to implement the microservices infrastructure architecture. Yeah. Now in AWS we talk about the ECS. We talk about the ECS orchestration, and then in other orchestration we discuss about EKS, and then for the hosting or the deployment, if you want to have a less effort, then you can use the Fargate, which is serverless, but you also can put the containers on the top of the EC2. Okay. Any questions before we move to knowledge check? No, sir. Ibu Ayu? Pak Fauzan? Ibu Hasna? Okay, then we move to knowledge check. So which description are characteristic of microservices? You choose two. Is it loose couple or tight couple? So it's, I believe it's a loosely coupled. Yeah. Is it redundant? Not necessarily. Yeah. Again, that's what we know. That's microservices. One service only do one job. Yeah. So there is no redundant. Yeah. Autonomous and independent. This is the most things that we believe useful for the microservices where it can independent. Yeah, so it's also loose couple. Yeah, tightly independent. So this is why the monolithic is not a good solution. Yeah, because it's tightly integrated. Yeah, and then interdependent, which is we want to have independent component. Yeah, so this is also not a good characteristic. So the answer is A and C. Tyson, do you understand why E is not correct? You always want to have a loose couple. So for instance, A and B application, every time you update A, you need to update B also. That is type or interdependent. It's meaning B dependent to A. Yeah. So you want to independent. Yeah. So A, whenever whatever what happened in A doesn't matter to B. Okay. Is it clear? Okay. So which description are characteristic of container? Is it portable and scalable? Yeah, it can be easy to move. Yeah. So, and then also can be scaled. Yeah. So this is one of the characteristic of container. That's why also the reason why people love to use the container. Require the hypervisor. This is actually for the VM. Yeah, this is why also why VM become not, even it is good, a better solution from the, for instance, the traditional on-premise and also physical server. VM give many beneficial, but one of the caveat of the VM that's they need the hypervisor. Yeah. So and then it's actually one thing that's actually uh, improved by using the container. Container is automatic, not necessarily. Yeah. So is it repeatable? Yes, it is repeatable. It requires own operating system. Now, this is also the caveat of the VM. Yeah. So every application tied to one uh, operating system for each application. Yeah. So this is not happen in container. Yeah. So again, this is why we choose the container. How are container in Amazon Elastic Container Service or ACS logically organized? How they organize? What they make? A, yeah, cluster. Pod is for the Kubernetes. EBS is not. EBS for is storage. This is also the storage. Yeah, so this is not a container. So right, it is a cluster. Thanks, Pak Haidar, Pak Yusuf, Pak Isan. Yes, it is a cluster. So I think this is the last questions. Why would developer choose to deploy the container to AWS Fargate over EC2? Is it because to control the infrastructure? No. The reason why people use the EC2 because they want to still manage the infrastructure or the EC2, the server itself. So this is not correct. To avoid manual infrastructure update. Yes, this is why, because you don't have to care about the infrastructure anymore. It will taken care by AWS. Yeah. Optimize the price? No, not necessarily. Manage their own patch and update? You still have to do the patching and the update. Yeah. So the best is avoid the manual infrastructure. Actually, this is part of this also. Yeah. Yeah, because manual meaning that you have to patch your own and then doing the update also. This is manual. Yeah. To avoid, then that's why we use the Fargate, which is the serverless. Remember that. Okay, by this, we finish our course today for the second day. And thank you for participating. Any feedback you can send to me. If you have a further question, you can send to me. You can also ask here. We have Pak Reza. Yeah. I think here also we have Hafid Gali. Then we can have the solution for you. Okay, thank you. And inshallah, see you tomorrow for the third day. Thank you.